Is that better? Ian, is that good? Okay. Sorry about that. All right, so let's go ahead and get started. Pre-registration is upon us. I heard people saying. There is probably some chance that despite this class, you might like to take other computer science classes in the future. Is that the case for anybody? All right. So here's what you need to take. Next semester, you should take Computer Science 052. It is the follow-on to this class. You should also take, if you want to take computer science in the future, if you possibly can, another class called something. It's an important math methods. That's it. I wanted to call it numerical analysis, but it was wrong. Math methods. If you take those two courses together and then you take data structures next fall, that is like the thing that unlocks every other computer science class. Okay, like in video games where you have to take a tutorial and then you can go to all the different levels. It's the same thing. If you get through data structures, you can. If you can't take two classes, you can take 052 next semester, math methods next fall, and data structures in the spring. Yeah. Are you a computer science major? Then I don't know is the answer. If you're going to be a computer science major, you have to. Now ask me why. I have no idea. So I think it would be much better if giving you a statistics class, but that's kind of the way the things are set up now. So. Okay, so next semester 052, Professor Malouf is who you're looking for. Given the opportunity, I think he's teaching it next semester. So, and then math methods, and I'm not sure who's teaching that, but if you can, take it with Cal Newport. Anybody you know Cal Newport? No? Nobody? He is one of the professors here, and while he's an excellent computer scientist, he is also a master at advising people on how to succeed in their career, from what I can tell, mostly through incredibly good time management. So he would also be worth taking. So, any questions about that? Newport, N-E-W-P-O-R-T. Also, one other thing. If you are going to take computer science in some sequence of classes, those are the ones you should take immediately. There are some classes you should take before you graduate, and they are electives. You will have your choice of electives, and this is my advice on which electives to take, okay? Definitely take algorithms. You should definitely take algorithms. You may not have to if you are a BA student or if you're a minor, but you should take algorithms. The other course you should take is databases. You should take algorithms because it is really the heart of computer science. It's a class on studying how to develop algorithms that we can turn into programs that we run. And it is essentially the class that will teach you how to ace Google job interviews. Like if you look at how people interview for computer science jobs, they often ask you, say, hey, given this problem, what algorithm would you use to solve it? And you have to develop an algorithm and defend it. So the algorithm class is the right one for that. Databases is just really useful. So useful. I never had a class. I ended up having to teach myself, which is the story of my life. And so you should have that as well if you can, okay? There are other good electives out there too, but those are the ones I really recommend. Personal recommendation, okay? All right, so that's for the future. Any questions about now, the project, anything like that? Yep. Okay, so the question is, when you assign control and experimental subjects, you do not have to use a random number generator. You should just somehow alternate between the two, okay? There is a bug in my program, which I haven't had the opportunity to fix yet. So if you run my assignment over the Lisbon file, they will come out uneven. Do not replicate that bug, okay? Do it your own way in a way that makes them come out even. So one of the things you can just do is you go down the vector, and if it's currently an N, you switch one to a C, you hit the next one, switch it to an E, next one C, E, like that. Okay? So, but mine has a bug in it. And like I said, I just figured it out yesterday. Someone told me. Who told me? Someone emailed me. Would you like some candy? So somebody pointed out there was a bug, and I sort of knew it, but I hadn't actually looked for it. So I'll try and fix it someday, maybe. Today is a 3-banana day for me. Yes? So the which to print character in the print function A should print out everything. Otherwise, it should print out C. If you put C, you should only get the control ones. If you put E, you should only get the experimental ones. So that's what it's there for. So we have, yeah, it's essentially the group, right? So we have one print function, and then just by giving that parameter, it tells us which one to print out. So we don't have to have a separate print function for each one. Does that make sense? Other questions? Okay, so I'm almost done with the exams. We had one student who was ill and just took the exam, so I should finish up the grading and release the exams to you. You'll be able to look at them online, I think. So by next class, by Monday, you should have seen them. Okay, and you can bring questions then. All right, so last time, what were we talking about? Functions and stuff, right? Yes? So let's write some functions. Let's write a function that does what? What do you want to do? Want to do some more adding? Subtract 3. And this will take an int. Okay, and so down here we can say int subtract 3. This will take an int, the parameter, and it will return what? We good? Does this work? What do you think? So let's go ahead over here, and here's what we'll do. We'll say double x equals 7.47, and we will say cout sub 3 sub 3 of x. Are we good? All right, so we'll just run this. We can compile it. What? What are you talking about? Of course it'll work if x is a double. All right, so it compiles. Oh my God. And now we run it. And we get 4, which is correct, right? 7.47 minus 3 is 4. What happened? Pardon? Why did it do that? All right, actually I think it happened here in the parameter. We put x here as 7.47. Is this a reference or a value parameter? Value, so it copied 7.47 into param, which is an int. If you copy a float into an int, what happens? Decimal's gone away. All right, well that kind of sucks, doesn't it? Change what? Okay, we'll make this int then. How about that? We'll just do 7. Is that better? We'll compile it, and it runs, and we get 4, which is what we expect this time. But this sucks because we really didn't want to subtract 3 from 7. We wanted to subtract it from 7.47. So what are we to do? Yeah. So change the int in the function here to doubles. And at the bottom. But what if we want to actually do x? And now let's do it with y. How about this? Because we want to subtract 3 from both ints and floats. Yeah. We could cast, we could do different things. But how about this? How about we just write another function that takes doubles? Does that work? Okay, so I'll get to it. I was saving that for later. Okay. Of course. Why would that be a problem? Can we name them both sub 3? Would that be a problem? Let's compile it and see what happens. The consensus seems to be yes, that will be a problem. Because 1 is double as 1 is int, okay? So here's the important thing. We had 2 functions. They had the same name, but It was possible to tell them apart, for the compiler to tell them apart, because the parameters were actually different. Right? Can I change it and make them the same? Oh, if we had int up here, again, it would give an error. You can't have two functions that have the same name and the same parameters. But you can have two functions that have the same name as long as the parameters are different. As long as the parameters are different. Okay? Because the compiler can tell them apart that way. And in fact, we can even make them do different things, right? We could make this one subtract 5, for example, and this would be fine. It would just be that our function name was a total lie if we subtracted 5. Right? Everybody with me on this? So for functions, you can have functions that have the same name as long as they take different parameters. Okay? So here we are. It's very important to us to be able to subtract 3 from things, isn't it? It's like just really important to us. So what other things do we have to subtract 3 from? What other types? Int, double. How about a float? Oh, I don't know how you subtract 3 from a Boolean. So we could do this again. We could do it with a float. What else could we do it with? Long, unsigned thing, short, long doubles. There's a whole bunch of different things that we could do this for. Right? Aren't there? How much would it suck if we wanted to subtract 3 from every one of these different types and we had to write functions over and over and over again? On the scale of 1, where it wouldn't suck very much, to 10, where it would suck like being set on fire, how many of you think it's worse than an 8? Of course not. It's minor. But it's you'd rather be set on fire than type. Typing is a 9. Typing is a 9. Yes. Anything, pretty much anything can be made worse by being on fire while you have to do it. Yes. Absolutely true. Okay. So if things suck, what happens? We develop a different way of doing things. Okay. I'm going to show you what we do. All right. What is the difference between all 3 of these functions? Is that it? Pretty much just the type, right? The type they take and the type they return. But are the type they take and the type they return the same for each function? Yes, they are. Okay. So here's what we can do. We can actually have a function that takes many different types. And the way you can think about this is what we're going to do is we're going to write a function that is known as a template. It is known as a template function, okay, or a function template. And the idea is that the type that it takes is sort of like a variable, right? Sort of like a variable. That when you call the template, you give it one of those types, and it constructs the function using that specified type for you. Everybody with me on that? Sort of? So here's what we're going to do. I'm going to create this template, and it looks like this. Anybody want to guess what the word that lets us know it's a template is? Template. Except I can't type. All right, we say template, and then we give it whatever we want. We say something like class T. And essentially, class T is going to be the type that it takes, whether it's int, float, or double. Notice that is surrounded by angle brackets. Is there some other place that we've seen angle brackets with the type inside? Yep, in vectors, right? So this is one of the ways that vectors work, because you can create a template that takes many different types. And then we're going to say what the return type is, T, and T here is kind of like a variable. We could put other letters here. We're just using T as a convenience. We give it a name. And I'm just going to put a T after that to differentiate the template from the other ones. Oh yeah, sorry, thank you. All right, sub 3. Who said that, by the way? Okay, 3. And then what do you think we have in here? Like this. Then we just say what we need to do in here, and we say return. Okay, so this is a template. Again, this class T tells us what type, and if we declare something that looks like sub 3T, it will look to see what's here and there, and will create a little function for us. So over here, let's do, I don't know, we already declared float. What do we want to do? Long? If we're doing long, we're going to make a big number, and we can see out like that. So what will happen when we compile this? The compiler will say, aha, sub 3T, and it's taking Z, that variable Z. What type is Z? What type does Z have? Long. How do we know that? Because right up here where it was declared, it said long. So what happens is it says, okay, the compiler says, I need to find this thing, sub 3T. Oh, look, I have this thing up here that says sub 3T. But I don't know what type to build it for. So what do I substitute here for this T? Long. Why is it a long? Because that's the type of the value that it was passed. Okay? So the compiler is helping you out here. So that instead of having to write separate functions for everything, you can write a template, and the template will figure out the type for you. All right? So let's make sure this compiles correctly. It seemed to. Let's run it and see if it works. And this now ends in 9.1, and it used to be 9.4, so that looked like it worked. In fact, you know, yeah? Yes, in this case I put it before the main because, remember, the compiler only goes through really one time, and so it has to know about it before it gets to main. So for the purposes of this class, if we use template functions, which we probably won't in the projects, right? Then you put it before main, so the compiler knows where it is. Okay. Yep. Okay. If the return type and parameter were not the same, you can have more complex formulations of the template that allow you to do that. Okay. Not going to get into that in this class. You will get more into templates if you take 052 next semester. But just wanted to show you this, right? Because it kind of sucks to write something that has the same type over and over again. You can write a template. Now that we actually have this template, I can show you that it works by putting this T after the other things, and we'll see that it works. The same template works for int and double and long, and it should compile cleanly, and we run it, we should get exactly the same answers, right, which we did before, but this time we were not calling the existing sub 3 functions. All 3 of those use that template function. All right, everybody good on that? That's kind of like, stuff like this in a language is often called syntactic sugar because it doesn't actually add to the capabilities of the language, it just makes it nicer for the programmers to work with things. Okay? So, any questions on template functions? If I asked you to write a simple template function, could you do it? I see mixed reactions, so. Any questions that you would have to ask me right now to understand it so you'd be able to write a template function? The 17-second rule is in effect. Go. Yes? Uh-huh. This is essentially, you can think of it sort of like a variable. But instead of holding a data value, it's actually going to hold a type. Okay, so when we call something, we call this x, the compiler looks and goes, oh, I'm calling this sub 3T thing up here x. What type is x? What type is it? It's an int. So what's going to happen is in this template, it's going to say, oh, I have an int here, so I have to replace this t everywhere with int. Yep, everywhere. So it'll find out what type it is and replace all instances of that t. And again, that t is not, it's just like a variable name, right? We could call it something else too. Yes, sir. For the purpose of this class, the template has to be above main. Okay, the question is now if we start mixing up our types so that we're trying to do something like subtract 3.5 from everything, and one of them was an int, what would happen? Whatever subtraction was defined for with 3.5, right? Most of the time, you want to do this in a way that you want to do this in a way that makes sense for what you're doing, right? So, like, could we put a string in there? We could, but what does it mean to subtract 3 from a string? It probably has some meaning. I don't know what it is off the top of my head. You want to try it and see? I'm a little scared. And what do you want the string to be? Dog. So, I really don't know what's going to happen here. All right, when you subtract 3 from dog, what do you get? Aha. Okay, so there's no minus defined for string, fortunately. So the compiler saved us. So, but we'll see later. It's possible. Anyway, I won't scare you with that. Okay. Any questions on this? Function templates. So whatever you're doing has to make sense for the type that's being passed in. Okay. All right, everybody good? Good. All right, 30-second stand up and stretch, break in place. Oh, by the way, I was like reading about how much more your brain works when you exercise, and even standing up works. And my mom called me a good person for giving you breaks, so now I have to do it. Oh, shoot. That refers to the type. Yeah. You can, and so the question, and because people are going to hear this on the video, and I'll just answer your question, so they hear it, it's okay. No, the question is why don't we just do templates for every function? Because not every function makes sense to do templates for. Like it made sense to do for this because we could subtract 3 from all those things, but it didn't make sense to do it for a string, right? So if your function is going to work with just like one specific set of data and not with others, there's no point in doing a template. You might as well just do what you need. But when you need a template, you might as well use a template. Different tools for different purposes. Okay, welcome back. I wrote a little program on the screen. Who wants to tell me what this prints out? Can you guess? Sure, you can guess. What does this print out? It's going to print 12, just 12. Any other guesses? Yes? 0 through 9 and then 12. So let's look at this program for a second. Where do we start? Int main. So you go here and we declare I equals. Okay? So we go down and now we declare a for loop. And what's in this for loop? Int I. Don't we already have an I? And what does this I do? It starts at 0, goes up by 1 until we reach what? 9, because it's less than that. And it outputs this, and then we output I. Yes? Yeah, but then after it increments it to 10, it comes back here, and it says only enter the loop if it's less than 10. So I will reach 10, but it won't be used inside the loop. All right. So how many of you think that we're going to get a compiler error? Anyone? Because we have 2 I's, right? You all think we're going to have a compiler error? Nobody's raising their hand. What? I saw me compile. Didn't have an error. Okay, so the compiler error theory is out. It's just right out because I succeeded. All right, so what's this going to print out then? 0 through 9 and then 12. 0 through 9 and then 12. So let's talk about what's happening here. Actually, do you want to do something really confusing? All right, here's what we'll do is we'll take this int out now so that there's no int inside the loop. There's no second declaration. And we'll compile it. What is this going to print out? It'll print out 0 through 10. Okay, so let's go back to the original one. Now that I have your attention, I don't want to baffle you, but let's talk about what happens. Okay? Let's talk about what happens. So as we step through here, we say int I equals 12. So we've declared a variable named I that has a value of, exactly. Now we get into this for loop. And we declare another I that's a different memory box that only takes effect inside these curly brackets. That's the only place it takes effect, is inside the curly brackets. Where a variable exists and where a variable can be used is known as the scope of the variable. What is the scope of the variable? And there are different types of scope, okay? So here, I has what is known as loop scope. It only exists inside this loop. The I up here has local scope. And local scope is only inside main. So when we need to figure out which I that we're trying to work with, we need to look and see where it is. And we have to look and see which curly brackets are enclosing it and if it is declared inside there. So this I has only loop scope. It only exists inside here, which is why we see out I, it goes, aha, there's more than one I. Which one is the most local scope? The smallest range. And it says, oh, the smallest range is the one that only exists inside these curly brackets, so I will print that out. When we get down to this second cout I right here, this I inside the loop is gone. It doesn't exist. It only has scope inside that loop. Okay? And so what happens is when we go here, we go, oh, we have to figure out which I it is. Well, this one's inside our curly brackets. This one's too local, so it's going to be 12. And it'll output that one. Yes? A constant will have exactly the same scope as a variable. So we can have constants. We could declare this right here. This would have local scope. We could have a loop constant. If we wanted, we could put one in there, and it would have only local scope. So constants and variables are exactly the same. You can treat them the same, except that you cannot change a constant. Everybody with me? So you see how this works, right? When we run this, when it's like this, we will get 0 through 9 from the loop I and 12 for the local I. right? If I take out this int right here and don't declare a new one, what ends up happening is the compiler goes, oh, I need an I. It hasn't been declared. Here is the only other one I know about. And so this I here ends up being the same I that is printed out down below, which is why those two things different. Okay. Sure, absolutely. So, so if we do this, right, here's what happens is the compiler goes, oh, int I is 12. It goes for I equals 0. It goes, oh, which I am I talking about? And the only I that it knows about is the one that was declared up there. So it sets it to 0. Is 0 less than 10? It prints out 0, adds 1 to it. We have 1. Is 1 less than 10? Keeps on going. Finally, we get to 10, and we go, is 10 less than 10? We don't. So it doesn't print out here, but then it goes down to here. And which I is here? The same one. So then it prints out 10 down there. Okay. Everybody with me on that? Not too many furrow brows today. You look less confused today. So, yep. All right, so let's put this back. I'm going to put this back for the time being just so it matches the comments. Okay? Everybody go with that? All right. Okay, so I've just declared a function. What name is this function? Yes, my pirate crew. Okay. So it has a function. Its name is I. And down here I say cout I, open close parentheses. What is this going to print out? 5. Why is it going to print out 5? Because it calls this function and the function just returns 5. Okay. Let me make sure this compiles. Something went wrong here. What went wrong? Yep. No, what happened here is the compiler is making it so that you cannot call a function that has the same name as a variable. Okay? So, and that is actually something that was added. When I used to teach this class, you could have functions have the same name as variables, and I would test to make sure you could tell the function apart from a variable by the existence of parentheses, but I can no longer do that. But the rule is, if there's a variable with that name inside scope, which in this case, int I is in scope here, so it works, right? In local scope, you can't have that function. So, all right, so we'll get rid of that. Everybody good with that? But here's what we can have. We could have another function called int j. And would j work? And we'll have j return 5. And I guess I should have saved that before and just changed it. And now we'll output j and see what that is. All right, everybody sort of with me? I'll just talk about what I did. Make the font a little bit smaller so everything fits here. Okay, so I declared a function int j because the compiler is nice to students these days and doesn't let me create incredibly confusing things like I used to. And I put in here, say, cout j, and what does j do? It just returns 5. So what is this going to print out now? Anything else? Just 5? All the stuff it printed out before and 5. So let's try that and see. All that stuff we printed out before, now it also prints out 5. Yep.
So if you didn't have the I in the for loop, you would be able to put a function in called I?
So the question was, if I didn't have the I in int main, and I only had it inside the for loop, would I be able to call, yes, let's try it and see. So we'll put that there. We'll call this one, make it S or something like that. We'll put S, we'll make this an I. The answer to your question, I believe, should be yes, because as long as there's not something in scope with the same name, it should work. There you go. So it works. So the question was, could we use I even though we're inside there, even though we used I in the loop? And the answer is yes, because it's not the same. I changed I to be S. Okay, and that worked fine. Okay, I'm going to put everything back the way it was. Or I thought I would put everything back the way it was. Wait, that one should be I. This one should be J. Okay. So yes, as long as it's not in scope. And the fact that the loop variable goes out of scope means that. You can use it. Oh, thank you. Okay. All right, make sure we fixed everything. Everybody with me on that so far? All right. So let's do some stuff. Let's change this. Let's make this int. Let's make it so we pass a value, and we'll put a value in there called I. All right, who's with me so far? Yep. Oh, yes, I do. Thank you. Also, I have so much Halloween candy at home. Oh, my God. We only had like 3 trick-or-treaters last night. All right, so that compiles. And now, what are we going to print out? This one will print out 12. What will this one print out? 12, right? Because all we're doing is, say, taking the parameter in and passing it. Okay, so let's see what happens. Oops. And we get 12 twice. Everybody still with me? All right, let's do this now. Let's put a local variable named I that happens to have the same name as the parameter. What's going to happen? Is it going to return 7, or are we going to get a compiler error because we've renamed something the same as the parameter? Compiler error. Okay? So, can't do that. All right, so just return I. Okay, let's have another function. Everybody can see what we're doing here? All right, scope works. Okay, let's have another function int j, and j doesn't take anything. And here's what we're going to do. We're going to say int j takes nothing, but here's what it does. It returns I. Okay, if we do this, which I is it going to return? Pardon? That's right, there is no I. Oh, I should have named this team. That would have been awesome. There is no I in team. Okay, let's compile it and see what happens. It doesn't know about it, right? It doesn't know about I. So let's give it an I it can know about. How about we put it right up here? Have we ever put a variable outside main before? No, we haven't. Let's see what happens here when we do this. Oops, sorry, I meant to run it, not compile it. Well, it would help if we called that one, wouldn't it? And then we would be able to see what happened. All right, j with no parameters. So let's just step through and see what happens, right? So we started at main. We set I equals 12. We get a separate I that has loop scope that prints out all that stuff. We output this I, which is not the loop scope I, but here. We call j with I. This 12 gets copied down here. And then we call j with nothing, which is this other function, down here that returns I. Okay. So when this returns I, is there any I locally here? There's no variable, there's no parameter, right? So which I is this one going to look for? The one up here outside main. So if it finds that one, if that's the one it finds, it should print out 74 as the last number here. And that's exactly what happens. It prints out 74. In fact, this thing up here is called a global variable. This I can be seen anywhere absolutely anywhere inside the program. Any function can see that I, any loop can see that I, anything can see that. Okay. Yes? Okay, so what happens is global is considered the least local scope, right? Whenever you have a variable, it's going to use the most, when you ever have a variable with the same name, it's going to use the most local scope. So this I right here has 3 to choose from. It has the I inside the loop, it has the I inside the main, and it has the global I. Which one is most local? The most local one inside the set of curly brackets is this one, the loop variable. So it will print that one. This I down here inside main will find the most local one, which is the locally declared one. But this function j that takes no parameters has no local scope at all, no local I. So it actually gets the global one. Okay. So, yes, sir. Can you? You can declare the variable up outside main, and then you can see into it inside main. Okay. But here's the rule for this class. We will never use global variables. Never, never, ever, ever. Global variables kill people. And I'm not joking about this. Okay? So one of the things that when we write functions is that because things have local scope, we can actually sort of reason about what's getting changed where, right? If you have global variables, where can those global variables be changed? Absolutely anywhere. So there is a car manufacturer, you might have heard them, they're called Toyota. Anybody ever heard of Toyota? Toyota had a problem where cars would suddenly start accelerating and they were not able to be stopped. Did you all hear about this? So Toyota first said, oh yeah, it's because the floor mats got caught on the floor pedal. And so NASA looked at the software and go, hey, the software is kind of messy. And then another company looked at the software, and their conclusion was this, is that their software, pretty much all the variables were global, okay, across their entire code base of the computer stuff that controlled the engine of the car. And what was happening was that because of this, there was a bug that overwrote this global variable for acceleration in the car and switched it from something that was a normal acceleration to maximum acceleration. It was a software error. And the maximum acceleration would cause the engine to rev, and people would try and brake, but if they were already at speed, the brakes were not strong enough to stop the car, and they would just burn out, and then the car would go full speed until it could no longer go full speed because it impacted a solid object, and people got killed. And in part because the software was poorly written in a way that made reasoning about what was going on. So, don't use global variables, okay? Don't use them. It makes things easier, but a lot of easy things are bad for you, right? Don't use global variables. Yes? Uh-huh. So if you want a variable that you're using inside multiple functions, you pass it as a parameter between each function. Okay? So before we had this global variable, we had no problem passing this I over to this function down there. Does that make sense? So if your question is how do you do shared variables between multiple functions and stuff, that's a different question that we'll answer later. Because sometimes you have multiple programs running with the same memory, and then there are different mechanisms for making sure it remains consistent. But we won't get to that in this class. Okay. All right, so global variables, kill is an extreme example. They are like the seductive thing. They fix so many problems. You don't have to worry about what's scoped where. You just call the variable. It's all great. But the problem is that it makes it really hard if something's going wrong in your program to figure out where. If you have a large program with a global variable and sometimes your global variable is getting changed, it's really hard to figure out where it's getting changed. You could have hundreds of thousands of lines of code, and you could have something where somebody meant to do int I equals 12 there, and actually just forgot the int part. Okay, they meant to have a local variable with the same name, but they accidentally got the global variable, and then the global variable is getting written elsewhere. Okay. Good programming practices don't use global variables. All right, do I use global variables sometimes? Yes. Am I an expert? Not really, I still get it wrong. It's just if I'm writing a small program, I'll be lazy, I'll throw a global variable in, and then what will happen is my program grows, eventually I go, oh, I have to fix the global variables, and then I have to go back and rework everything, and I end up doing that. So, now, one question though. If we can't use global variables, can we use global constants? Yes, this is okay. All right. Global variables are bad. Global constants are okay. It's the fact that they can change. And just by making that a constant doesn't change the output of our program. Our program still works just fine. Okay. All right. So this is essentially the idea of scope. Scope says where something is valid. And things are only valid in the particular set of curly brackets where they're defined. So you can have loop scope here, you can have function scope, you can have global scope. I'm going to show you one other thing. This has virtually no use, and I'm not entirely sure it's going to work in this compiler. But you can also create something that has block scope. Okay. So here I just put a couple of curly brackets to create a block of code. I put I equals 3 in there. Did I print it out? Yes. And so if this compiles, which it does, and it runs, we now have 3 at the bottom right there. Okay. Just like you can create this loop has its own block, you can purposely create its own block right here. So. So there isn't much common use for this except to confuse students. Okay. All right. So what kind of scopes have we seen? Somebody name a scope that we've seen. Who said local? Who said it first? Got some candy for you. All right. Yes. Loop scope. What else? Global. What? Block. Who said block? Oh, sorry, that has nuts. Wait. Oh, sorry. All right, any other questions about scope? Oh, sorry, look out! That's my worst throw of the semester. Sorry about that. Anyone else? On the rebound. Okay. Oops. Oh, no. All right. We're going to stop before someone gets injured today. So, any questions about scope? Yep.
Can you just try and give a general definition for what it is again? Just I think I have an idea, but I don't know how I would define it.
Scope is the part of the program in which a variable is valid. Okay? And not only valid, but like recognized and known about. I'm sure that the programming language theory people have a much better definition than that, but that's the way I think about it. It's like, where can I see and use this variable? Yes, sir. Yes, block scope. The idea of this is that if you create an area inside curly braces, which is I've done here, that's called a block of code. And inside a block, you can define a variable that has scope only inside that block. In fact, what we're calling loop scope here is really just an example of block scope. They're not particularly different. But most of the time when we have a variable associated with a loop, we have that. This block doesn't actually have a loop. It's just some code that we put inside curly brackets. So for example, you could do this inside like an if statement or an else or something like that and have your own variable inside that if or else statement. in general, like you don't want to do that, right? Because this stuff, code. All right, what is an algorithm? Series of order steps completes the task. What's a program? Yes, is correct. No, it's an algorithm that a computer can execute and people can read and understand. And if you do tricky stuff like this, it just makes your code really hard to understand. Okay? I want you to understand that this is possible, but I don't want you to write code this way. Got it? Everybody good? Any last questions? All right, 1 minute break in place. Ready, set, go. All right, welcome back. I have a couple more things I'd like to show you about parameters and then I'd like to introduce you to the concept that we will get to next class, okay? So let's say we're writing a function, and the function that we're writing is we're going to raise something to the power of something, right? Okay, so we need some math. We're going to be doing some power things here. Make sure this is all working the way I want. Okay. All right, so we're going to, okay. So we want to write a function that does the power of things. How would we write a prototype for that? And what are we going to take as parameters? An int and an int. Okay. And we will just down here, we'll write some x equals 2, int y equals 7. And then down here we can see out whatever that is, right? See out, angle, power 2, 7. And all. All right. So now we write our function. We say int power takes 2 ints, int a and int b. And what are we going to return? All right, so this should return to... I figured out what happened. I bumped it with my knee. There we go. Okay, much better. Okay. Yes, I do. Is that your question back to? Yeah. I don't think so. Let's try it and see what happens. Clear the screen. We'll make sure this compiles. And we can just run it. And we get 128. 2 to the 7th is 128. So that seems right, right? Now, let's say, just out of argument, that we're going to be doing a lot of raising things to powers, okay, in our program. Except almost every single time, we're going to be raising it to the power of 8, for example. What we can do is we can make it so that if we do not declare anything otherwise, that it will do 8 by default for the power, okay? And here's how we do this. What we can do is in the prototype, we can define the variable name and what value we want it to be. Right up here, this declares the default parameter. And the default parameter says, if you don't specify a second parameter, then use b equals 8. So here's what we'll do. I'll show you how this works. We do cout, power of 2, endl. Now you might say to yourself, Clay. All right, we've seen that we can have functions that have the same name. We have no problem with that because the compiler can tell them apart based on the arguments, on the parameters, right? But this one only has one parameter, and the only function we have with that name takes 2, right? Isn't that a problem? No, it's no longer a problem because what we've done is we've put in here int b equals 8. And what the compiler will do is it says, oh, I see we have power. There's only one parameter. So if there's only one, I will fill in the other one with this default parameter. And it will use 8 by default if there is nothing there. Now notice you're going to see this doesn't affect our other instance of that function because we put a 7 there and we'll go, well, if you put that there, that 7 there, I will use it instead of 8. But if there's nothing there, I will use the 8 instead. So if we recompile it, it still compiles. If we run, we get 2 to the 7th right there is 1/28th, but 2 to the 8th from this default parameter is 256. All right, everybody with me on that? Yep. Yes, if we tried to create one more function, and so if we said, int power int like that, and then wrote it out, the compiler would not be able to differentiate between the function that only had one thing or one that required a thing. The other thing about it is if you're going to have a default parameter, it must be the last one. It must be the last one on the list. So for example, we couldn't do int a equals 7 as a default parameter if the second one was like that, because then it can't tell which one it's supposed to fill in. We could if we wanted to have 2 default parameters, that would be allowable, right? But if you're going to have default parameters, they have to be the leftmost ones. Yep. No, this is literally the compiler just saying, oh, I only have one thing here, so I know I should fill it in with the other over there. So, yep. Yes. I don't know if you have to have the same name, but in practice you should. Like, I don't know if we can put like X up there and have it work. You want to try it and see? The compiler might still like that. Yeah, it works, but I think I would use the same name just to be consistent. Okay, so now notice I put a default parameter for A as well, and I can just leave both out, and it will tell us what 7 to the 8th is. That's a big number. How about we do 3 to the 8th instead? Now we get 3 to the 8th in there. So all of these are valid because the compiler is able to figure out defaults. Do you have a question on the side? Yeah. Can you set the default parameter to a variable? I don't believe so, because this thing has to be done at compile time, like when the compiler runs. So I don't think you can just say, hey, set it equal to some variable. We don't have global variables. They don't exist. So much like I tell my children that Star Wars 1 doesn't exist. There's no Star Wars 1. They went straight to 2 and 3. So, yep. Okay, so here's the deal. This one, it doesn't have to make any decisions because both are there, right? This one, it has to make a decision, and if it has to make a decision, it always uses the leftmost one first, okay? So it just assumes that if we're putting number, it's the rightmost one. Wait, I have those backwards, don't I? Jeez. Okay, so the last one, how's that? It always uses the last one first, which would be the rightmost one. Sorry about that. You would have to switch the order of the parameters in order to do that, because it always takes the last one first. So, what? This one right here, yes, does 2 to the 8th, because it says, okay, I'm taking a 2, so I'm going to put that in the first one, and then I'm going to assume the last one, which is on the right, is an 8. Yeah, left and right get me, and also greater than or less than. So there was a time I was applying to be a pilot in the military, but I saw myself like killing my wingmate by saying, missile coming, brake left. No, I meant right. So that didn't happen. All right, and then power, there's nothing in there, so it uses all the defaults. Okay, everybody good with that? All right, there's one other thing you can do, and I'll just show you this really quickly. We'll just create something. Let me just check. I don't think you need this in the prototype. I think you can do. You can have constant parameters. You got to do it in here. So you can have constant parameters where you say the thing is going to be a constant, and then it is not allowed to be changed inside the function. Okay? I'm just going to tell you briefly, most of the time you use constant parameters. Most of the time you use constant parameters. You use them when they are reference parameters. The idea being is that you can give a reference to something, it goes into the function, and that function cannot change the reference. Okay? Now the question you're asking yourself is, but Clay, aren't we using these references to allow us to change things? Isn't that what we're doing with references? And isn't it setting it to a const mean that we can't actually set it as a reference anymore? Yes, it does. So here's why we do this. Say that I'm the NSA, and I have a big list, and it's the list of everybody in the country and all the phone calls I've ever made. How big is that list? Say I wanted to pass that into a function. If I passed it as a value parameter, what would happen? How do values go from one place to the other? They get copied. So if we had to copy this giant list, what would happen? Your computer would start copying the list. It would grind to a halt. And like 2 days later, it would be like, okay, I've copied everything over. I can do the function now. Okay. A reference parameter doesn't get copied over because it's like a link, right? But the danger of a reference parameter is if you pass a link, someone might upset your whole giant data list that you have. Let's say everything's in a vector, right? But if you make it a const, what ends up happening is they can't change it. So this is what you do when you have like a very big data structure that you have to pass into a function, like a very large vector, way bigger than anything we would ever use in this class. You want to make sure that even though you're passing it, it doesn't take a long time to copy, but at the same time it can't be changed. Okay? I'm just telling you this. I don't expect you to do this in this class, but I want you to understand it in case you ever see it anywhere. Okay? It's just a way of not having to copy a huge thing over from one function to another. Okay. Everybody sort of get that? Just in case you ever run into it. Do you want to see one other thing that you should never use? I'll tell you later. I have a bunch of stuff I'll give you right at the end of the semester, like on the last 2 days. It'll be like, here's all the stuff that you can never use and that you wish you had known earlier because it would have made your life easier. Okay? So, what? Look, if you were learning to drive and I gave you a Google driving car, have I done you any favors? No, not at all. So, some of the stuff I will tell you at the end, I'll be like, oh, we could have done this before and it would have been easier, but you would not have learned as much if the computer does it all for you. So, right? All right. Any questions on this? All right, so I'm going to try and draw some pictures here. So, throughout the course, we have been talking about a couple of different things. We have been talking about, any questions before I go on? This is a new topic, and it's going to kind of get into what we are getting into later. Okay. Any last questions on functions, parameters, constant parameters, default parameters? All right. So throughout the course of the program, we've been talking about a couple of things. We've been talking about code that executes things, and we've been talking about data. Okay. In the early days of the class, all we had for code was int main. All our code was in there. Do you remember that back in the good old days? What did we have for data back then? Pardon? Nope, not even a file. Back when we started, all we had for data was individual variables. Right? So this was like the old days. The very old days of September. All right. Everybody remember this? All right. And as time went on, what happened? Did we only have individual variables? What did we have? We had vectors. Well, we had files, right? When I say data, I actually mean what's being held in the boxes of memory. Okay, so files are someplace else. So we do have files, but when we read files, we put them into individual variables or we put them into vectors. And what is a vector? Yeah, it's like something you can put stuff in, right? Like here, this bag is my vector of candy. Although this candy is not particularly ordered from 1 to n, right? It's not well ordered, but just like we have a whole bunch of things, like the size of candy in here is roughly 20, right? And I can just pull them out. So the vector is just a container for other things, which was more convenient, much more convenient. Can you imagine working on the project 3 or project 2 if you had to have like 100 separate variables, one variable for each person's ID and stuff like that? That would suck, right? It would just not be feasible. So we have this. Then the other thing we got in terms of code was what? Functions, right? So instead of being limited to just having code in main, we had functions. Now functions are nice because they allow us to take code that we're going to use over and over again and not have to type it over and over again, right? So for this last project, you're using functions, and we used, how many of you used average? How many of you used standard deviation? How many of you in the compute statistics called the average and standard deviation? That's how it's set up, right? So the compute statistics should just call average and standard deviation. You don't have to do things over again. So functions allowed us to redo code. But there's a weird thing about these functions, right? The functions that we're writing or have written, if you've already finished it, for project 3 are really, really, really specific functions, aren't they? Like, what are they specific to? To the project. So, yeah, and to the types that we're working with. So the functions that we've written take like 13 different vectors, right? How often are you ever going to use those functions again? Like if you come across another project, is there ever going to be another project where you're going to go, oh, I remember that time I wrote that function that had 13 vectors that happened to be an unsigned in, an in, an in, a float, a double, a car, right? Like in that particular sequence. You're never going to use those again. And that's bad, right? Computer scientists are lazy, but we're lazy what? In a good way. We want to get the most result out of the minimal effort. So what we're going to start talking about is a way that we are no longer going to be combining, no longer going to be separating functions and vectors. Or functions and data, I should say. Because our functions are so dependent on our data, we are going to start operating in a way that combines the data with the functions. So that if you have something, like maybe a experimental subject that has particular operations that can be happening on it, you will also have the data combined as well. And what this is going to be called is we're going to combine these into things that are called classes. Okay? A class is kind of like a function that has its own data. It's kind of like a bunch of data that has its own functions. It's a combination of the two. And what a class is going to be the blueprint for something called an object. Okay? So what we're going to be able to do is we're going to be able to say, look, instead of having 13 vectors, each slice of which at a particular point represents one experimental subject, we're going to develop an experimental subject class. And in that experimental subject class, each object will represent one subject. Each object is going to have its own subject ID, age factor, weight, BMI, all that stuff. And we're going to have functions that operate on that object. So for a particular object, you will be able to say, hey, what's your weight? And the object will say, oh, 86 kilos, or whatever the answer is. Right. And it's a different programming paradigm. It's going to be a little bit different than what we're doing, but the idea behind it is this. Instead of having functions that are separate from the data, we are merging them together. And the object will carry its own data, and it will carry its own functions that operate on that data. Okay. Everybody see where we're going with this? Does that sort of make sense? Like, it's a pain in the butt working with 13 different vectors, right? Wouldn't it just be easier if we could have an object that said, oh, here's an experimental subject, and it's one subject? Or we had a whole bunch of subjects and we said, what is the average score of these subjects? We would ask each subject, hey, what's your score, what's your score, what's your score? And we would average them up when we're done. So that's where we're going to go with this next in the class. See you later. Have a good project 3. Oh, project 3 compile and format check for the autograder is up. I'm still working on the grading part. I have some bugs in that. So.